All right, hey folks. Hope everybody's doing good. Cool. All right, so just a quick reminder to please bring your questions if you want me to go over them on stream. And it looks like we've got one already, which is great. Thank you. So, challenge 3 in this link. Okay. Come back over here. Let's go to challenge 3. Find primes. Let's see here. Did I not? Oh. I have that period in there. That'll do it. Okay. Number 3 in breaking loops. Find primes. Complete the find prime function according to its docstring. Okay, lovely. So find primes takes in nums. Let's write a test. Find all the prime numbers in nums. Returns those primes in a new list. Okay, so find primes should take in a list of numbers that may or may not be prime. So let's do this. My list, and we'll make my list equal to my list equals a list of numbers, and let's do oh, you know what? I'm just going to do a list of a range. List of range 10. Okay. And basically what this is going to do is just go through every number between 0 and 9, including 9, and just tell us true or false whether it's prime. So we should see 0 is false, false for 1, true for 2, true for 3, false for 4, 5 is prime, 6 is not, 7 is prime, 8 is not, 9 is not. Okay, so that's let me do this. That'll be there we go. Okay, cool. So this is our output pattern that we want to see. False, false, true, true, false, true, false, true, false, false. Okay. Cool. So this is, it's kind of funny. Usually for this, so this is essentially the function that I use to test when I write an is prime function, or at least the similar logic. I usually don't make it a function, but we'll take this sort of step by step, and we'll discover the need for an is prime function as we go. So finds all prime numbers in list, returns those primes in a new list. Parameters, a list of integers returns a list of all the prime numbers found in nums. Okay, so we can do this for num in nums if the number is prime, and I'm just going to do is prime. If is prime num, list dot append num. Pretty easy. So this is going to be all the code we need for this one. We could write the is prime logic like in line here, but it's such a contained algorithm that it makes sense to just break it into another function, which we can totally do in learn here. We can have a helper function, and that's what I want to do. You don't have to do it this way, but well, you should. Okay, so this is going to take in, I'm just going to call this in, and we'll say def is prime in takes in a number, and we'll say so for I in range, we want to start at 2 to n. We'll just do 2 to n. There's a way to make this range more efficient, but I just want to keep this as like a simple, easy to read algorithm. So so what I'm going to do is go through a range starting from 2 to n. Why should I start at 2 and not 0 or 1? Because I intend to divide if the remainder of n over I, right? And since I want the remainder, I'll do modulo. So if n mod I, mod I, if n mod I equals 0 at any point, then I know that n is not prime, so I can just return false. And I believe this is in, this is in the breaking loops challenge. So what I think they want me to do is this like prime, make a prime variable, and then set it to equals false here, and then break, because this is a lesson on breaking loops. I don't like doing it this way. I think it's just kind of clunky and less elegant than just returning false once you know that you need to return false. So I'm just going to do that. The reason we don't start at 0 is if I do n over I, and modulo is a type of division. It just gives you the remainder instead of the quotient. So this is still n over I, and if I try to do n over I where I equals 0, we'll get a 0 division error. This is, some of you may know, I'm presuming many of you may know, presuming most of you know that you can't divide by 0, or there's some argument actually about what that even is, whether or not you can divide by 0. Some people say it's infinity. Some people say it's undefined or not a number. Python's opinion is that it can't do it, and it's not going to give an opinion. It's just like, I can't divide by 1 because n over 1 is 0, no matter what n is. Every number, every whole number or integer in Python is divisible by 1 evenly. So we don't want to start at 1 because that's going to give us a false signal. Same thing with why we don't include n, because n over n is 1, no matter what n is. 62 billion over 62 billion is 1, so we don't want to include n. And there's a way of doing this. If we did, I think the smallest thing you can do here is the square root. So if we iterate up to, and then I think we need to include the square root plus 1. Up to and including the square root of a given number would be the smallest possible set of numbers that we could. We'll often say, well, maybe you could do n over 2, or there's various things you could do, and I think the square root of n is the best one, but yeah, doesn't matter. Okay, and then from here, so we need to handle. We left ourselves kind of an edge case, because what if n itself is less than 2? If n is less than 2, we need to return false. We're just going to return false. And then otherwise n is greater than or equal to 2, it'll run through this loop. And if we make it through this whole loop without returning false, then we know that I or n has no factors, which means it's a prime number, so we can return true. And I know I'm not using break at any point here, but I prefer, like I said, I prefer to just return directly when the time is right. So now that justifies having written this line, this is prime line. And to anybody who I've worked with where we've like excuse me, where we've built an is prime function together, right? Or you might have seen me do this in Premium Prep or something. But this is basically a test for the is prime function, right? And that's the logic for our find primes function here. Cool. So let's just run it, make sure we get the correct output pattern. Oops, I gotta. Oh. Parent is not defined, but print is defined. Oh, right. I'm not doing this, I'm doing something else. Okay, so the true ones are 2, 3, 5, 7, and that's what I have in my list. 2, 3, 5, 7. Okay. I got kind of off track with the output pattern there, but that's fine. I still wound up with the right answer. And let's submit this. Check it out. Yeah, there we go. It looks like they broke out a is prime function as well. Let me just paste this into my editor. We can kind of look at them side by side or top to bottom. So this is their is prime function. I'm gonna just, I'm gonna just clean out the comments here. Right, so they're taking a Boolean flag approach, and they're doing this if n is 1, and this should really be just less than or equal to 1, in my opinion. And then elif n is 2, return false. So they're handling this as a special case. My logic just handles it naturally, because if we have this, if this range is 2 to 2 and the upper bound is 2 as well, and 2 is not included, then you have a range of 2 starting at 2 going up to positive 1, but it can't go up to 1. It could go down to 1, but it's not going to, because the step, unless we supply a step of -1, the step is assumed to be positive 1. So this is like an inverted range, which just means we don't have anything to loop through. So this is kind of like a nullified or an inverted range. So what that means is that we just don't do any loops. We just don't iterate at all, which is good, because if we did, we'd do 2 over 2, which is n over n, and we need to handle that. So with this logic, it just skips this loop and then goes straight to returning true for 2, so it happens to work out. But with this one, they're taking a special case for 2. And then finally, else, this is our primary case here for I in range, This is the optimization that I was talking about. We could do this here. We'll just do it there. So they have this loop optimized a little bit. And then if n mod I equals 0, n mod I equals 0, prime equals false, right? And then they break the loop and return prime. So either prime stayed true from up here, or prime was set to false, and then the loop was broken. To me, like if you have a if you have a loop that you break, and then outside of that loop, the next thing you do is return, you could just return because that's just a default break. I don't know. To me, that's what I'm used to doing. I think it's more natural and preferable. But really, it is just my opinion. And that's a good example of how, or it's an example of how to use break in a loop. Cool. Will I pay? Let me run it first. Make sure I'm going to paste working code. Didn't do something silly. Okay. No silliness done. Oh, come on. All right. Looks like we're good on that one. We got a couple, or we got one more question here, which is good. Okay. Oh, come on. Ooh, we got a weekly challenge. So let's see. Which week is this from? Ah, I just made a video for this one. The last weekly challenge from 2/8. Yeah, quick note on the weekly challenge is I got behind on doing the videos, but I'm going to get caught up on that. Those will get caught up this week. We've got a break from premium prep, so I'll have free time to get those caught up, and we'll have weekly video or weekly challenge videos out every Friday on time henceforth. Sorry for the delay. I just made and posted mere hours ago a video solution for this, but I don't mind doing it on stream as well because it's a good problem. Cool. Oops. Well, yeah, we'll just do that. Okay, so this is the weekly challenge. So the third one. So quick thing here, and I think, yeah, I was worried that this would happen. There is I think this is the corrected. Yeah, so you might have been looking at old examples. Let me read through your question all the way here. Having trouble understanding the example output. If the second item in the returned tuple is supposed to be the number of midpoint calculations, shouldn't it be 2 for the first example? So yes, if we were starting at 1, but we're starting at 0. I had to make a correction to these the other day because in the examples they were starting at 1 for these first two, but these two were starting at 0. And if you look, so these two were correct, and recently I had to correct these. So it kind of looks weird, but if you look at the other two tests, it's saying 0, meaning like it found it the first time through. And honestly, that, I don't know, if I had written the test for this, I probably would have started the count at 1. But I mean, not that that's like the way it should be done or whatever, but that's probably what I would have done. But whoever wrote the test for this decided to start the count at 0, which is, I mean, we're computer scientists, so that's fair game, so. All right. But yeah, let's actually look at a solution for this. And we'll kind of go over this. Okay, so there's a few assumptions that we're making with this problem. Here's the first two. And then I should really go back and add this as well. The count of midpoint calculations starts at 0, 0 being the first calculation. Starts at 0 with 0 being the first calculation. So if we find the number on the first try, we're going to say 0. So that's kind of a weird one. Oops. Pretend like that solution wasn't on screen. Okay, cool. So for this one, we'll just start off with, let me see if really quickly find I believe I just saved my tests that I had. Yeah, here we go. Hot off the presses. So I added a couple tests of my own, these first two. Let me try to get this, turn the size down a little bit, that'll do. Cool. Oops. Copy that. Def bin search, we'll take in a list and a target. So basically we can think about this as the binary search algorithm. We start in the middle of a sorted list. We're looking for a specific element that is in the list. The reason the list needs to be sorted is we start in the middle and we can tell if the number we found in the middle is too low or too high. So if the number is too low that we find in the middle, we would move the if the number is too low, we recalculate the midpoint based on the old midpoint, which is now the new lower bound, and the old upper bound, which is just the end of the list, and we move the midpoint up to the midpoint of that, right? So the way we can do that, the way we can do this midpoint calculation is whatever the index of the lower bound is plus the upper bound, the sum of that over 2. So first we need the lower bound, and I'm just going to call it lower, and upper equals 0, and len list minus 1. I'll just be nice and clear about this, put that in parentheses. Lower and upper equals 0 and length of the list, and our midpoint is equal to lower plus upper. The sum of this, we need to sum those and then divide this by 2. And I always like to cast as int as opposed to use floor division, but it doesn't really matter at all. It's just the way I do it because it's the way I do it. let's see. So lower, upper, mid, and since the second thing we're returning is the number of midpoint calculations, I'm going to count those in a for loop. I'm just going to use a for loop to run a counter. So I'll say for count in range len list, and we'll recalculate the midpoint every single time. From here we can say, we can do the partition moving, as it were. We can say if the number we find in the middle, which is list submid, so if list submid is greater than target, then we can move our upper to our mid. Else, we'll move our lower to our mid. And if our list submid is equal to our target at any time, then we can just return mid and count. Cool. And this is probably character for character the code that I actually submitted. Yeah, it looks like it is, so I need to paste it in. So that solution should work, and that's hopefully that'll help you think about it. And apologies if there was any confusion about this. I think I'll probably just go add this copy in into the notes here about the assumptions. Yeah, that way that's clear what's being assumed there. And do let me know if that was helpful. Cool. I'm not seeing any other questions or comments. Do feel free to put them in. Don't be shy. That's what makes study halls, I think, fun and useful for everybody. So go ahead. We got a comment here from the question asker of the previous one. I opted for a recursive solution, so I think I need to walk through a few loops to see where my solution is different from your code. That's cool. Recursive solutions, I like recursion. That's a lot of fun. My personal feeling is I always start with like a simple, like a for loop if I can, and if I can't use a for loop, then I'll use a while loop, and if I can't use a while loop, then I'll use recursion. So I'll kind of step it back to what I need. But yeah, I think, and I'm not sure if you got a working solution with a looping context, but yeah, then you can kind of work your way back through to a recursive solution. And I'm not sure. Now I'm curious. Can I just do this? I might have to think about this. Let me just see if anything occurs to me really easily, though. We could do something like, oh gosh, now I want to do this. Now I want to do it recursively. I don't know if this is going to be quick or not. I'm just going to give it a quick try, see if I can show a recursive solution since it was mentioned. Okay, so probably want to take in our counter, and we'll start this at 0. Let's see, what else do we want to do? Have anything else? It's kind of just that. Well, I still have to pass the lower and upper. Yeah. LWR equals 0. And see, I can't do upper. Can't do upper here because I need the length of this. So yeah, this is starting to get wacky. Starting to get pretty wacky. All right, I'm going to back off here. Perhaps I'll do a recursive solution video for this and post it later. Oh, no worries. No worries. It's always good to ask. Sometimes you gotta think through those, and it can take me. I don't think it'll be too long, but I just want to use people's time on study hall well, and you know, cool. Mm. Yeah, I'm looking through your solution. You need to it. I think you need a way to. Um, let me just pull in this solution here, and then I promise we can move on from this question. Oops, come on, Slack. Let me read it. Thank you. Okay, so here's the solution in question. So, my guess would be the that you'll need to make this somehow dynamic, right? This length of this L, right? Because this will work for the first time through the loop. You are doing that. You're slicing. Okay. Now, looks like you're on it. Okay. I'll leave you to it. That's going to be a fun solution. Cool. Okay. So let's see here. Let me get back to here. All right. Well, I'm not seeing any other questions at the moment. On to where we were in the material. Do feel free. The questions are the priority in general, so do feel free to post your questions if you've got them, and I'll take them from there. All right. So the count method. We're talking about the count method today. Kind of a major shift of gears here from recursive binary search to the count method, but it's good. We've got a little something for everybody today. So the count method will allow us to count some number of elements in a list. And I'm just looking for a list up here. I'll have to make a list. List equals, let's say, you know what? Let's kind of use a more tangible example. I like this example here. So I have this is my notes document with all sorts of little useful snippets of code and stuff. It's like very long. Anytime I do anything, I just throw it in the notes document. It's like about 10,000 lines right now. And I have a stack of these notes documents as well from years of doing things this way. but I have this little text bit right at the top, and one has punctuation in it and the other one doesn't. And this is for just so I have something to play around with when I want to play around with text. So here's some text, and I'm just going to say list equals text dot split, and that will split my list or my text into a list of words. And actually, I think I want to do that lower dot split. So this will lowercase everything and then split it. So let's, which is a list of words. I think this is a good place to. This is a good way to demonstrate the count method, right? So let's look for something that shows up in here multiple times. I, the word I shows up a lot. So let's do list.count I, and I'll do lowercase I because remember I said lower dot split. So it says 5. It says there are 5 words I, right? And these are the elements in the list, right? So if I select this 1, 2, 3, 4, 5, so that's 5 I's. Notice how it's not counting, you know, there's a bunch more letter I's in here, right? Here's one here and one here, right? But remember, it's the words are now the elements in the list because of what I did with split here. But this is, I think this is a good example of how to use count. So I have a list, actually, or a string or a tuple. Count works for a string or a tuple as well. And I can just, if I want to know how many times an element occurs in that object, I can just say, you know, list.count and then the item that I'm curious about. So if the item doesn't show up, like let's say watermelon, right? So watermelon is not in this body of text. If I try to list.count watermelon, I'm just going to get 0 because it says watermelon doesn't show up in that text. I really want watermelon. I've been thinking about it a lot lately. That's what this is about. This is my subconscious letting you all know that I would like some watermelon. But anyways, so cool. Count is, it's simple. It's a simple method, you know, just call it on a list, a string, or a tuple, pass in an element to look for in that collection, and it will tell you how many times it showed up as an integer. So yeah, it's a good one. I don't even think we need to go through this too much, so we'll just go through the challenges and move on. What value will count of items have after this code block is run? Let's see. Well, actually, my knee-jerk reaction is just copy paste it and like run it, which is fine. But I could also. This is a really easy one. So how many times does 1 show up in here? 1, 2, 3, 4. So it looks like 4, unless I counted wrong, which, you know, I'm prone to do. Happens. Okay. Here's an example of how the function should work. Okay. Write a function. Here we go. Okay. Takes in list and some elements, A, B, and C. I don't know. Let's see. Okay, so write a function called sample percent that takes 4 parameters. The first parameter, obs list, will be a list of observations. The second, third, and fourth parameters will be called group 1, group 2, and group 3. Okay. Okay. They are objects whose counts should be recorded. The function should return a list where each item is a percentage of the count of its respective group relative to the total number of elements in the list. Okay, so then like the percentage of time that it showed up in. So I think if we do, so this input should give me 0.5 for dog, 0.25 for cat, and 0.25 for fish. So let's just see if we can try to do that. So dog, you know what? Okay, well, I'll keep, I was gonna change these back, but all right. So let's do this. And I think we'll just do this like a kind of a standard accumulator. I'm just gonna say for obs in, and I'm just gonna make a tuple literal for this to iterate through. So these 3 elements. We need the len of observations. We'll call it obs len obs list. Okay. Okay. So if I say print obs list dot count ob, we should get 2, 1, and 1. Okay, and then if I do this obs len like that, obs len over the count, I think that's it. And then is it, wait, it's 1 over, I'm being silly here. Why can't I, the count of the elements, oh, it's just 1 over this. 0.5, 0.25, 0.25. Okay, cool. So I'm actually just going to replace that there, get rid of this unnecessary variable, and we'll say list.append. Cool. That should work. Oh no, formatting. Alas. We've got an error. Oh, 0 division error. Okay. So one of our things, it looks like, yeah. So if the count of something is 0, like if we had another test where we're looking for horse, cat, and dog in test list, let's see what test list. Yeah, so it says dog shows up 0 times. So it looks like it's looking for dog in a list that has that did not have dog in it. Oh God, there's something just really simple about this that I'm not doing here. Is it just multiply? It's not that. Hmm. I think, does this give me the complement? Could I just hack this? No, it does not give me the complement. Okay. I am having a total brain fart at the moment. Well, we could just, I could just handle this like this. I'm going to call this ob count equals this. And we'll say, oops, ob count and we'll do this if ob count greater than 0. Else list.append 0.0. Cool. So if I do this and I look for horse, okay, so that handles 0 now. I feel, gosh, I don't know why I'm having a moment with the math, but that's a nice thing, you know, conditions just make it work. Okay, so let's see what they did. Oh my gosh, it's just the count over the length. Gosh, that's just so incredibly obvious. Okay, let's do it the right way. Okay. And looks like we're down a set of parentheses. So there's this one, that one, and that one. Okay. Try that. And that'll do it. Okay. All right. All right. Well, there you go. When you forget how to do the most basic things, that's okay. Happens. All right. So let's go on to the next one. Is it this one? This one. Okay. Here I said count was simple. Okay. So complete the function called here we go, which takes a list as a parameter and returns 1, 2, 3, 4. This will be 1, 2, 3, 4. the sorted version of the list, reverse version of the list, the last element of the reverse version of the list without removing it from the list, the number of times that the number 22 occurs in the list. Okay. Do we have any? No? All right. Function that does things. Okay. So it looks like we're taking in our parameter, which is a list. X is a copy of the parameter. So this is kind of funny because we really don't need to copy it in this case. What we can do is, what do we want? The sorted, reversed, last element, which is actually the first element. So I'm just going to do the sorted function reversed with a slice, colon, colon, -1. The first element, which is the last element of the reversed list. And what was the last one? Oh, the count of 22 dot. Cool. I didn't even use X or Y or copy. We don't need to use copy in this case because oops, there we go. Because we're not causing, the way I'm doing this isn't causing any mutation in the list whatsoever. So sorted and reversing in this manner don't problem. Sorted copy. Ah, okay. So they really want it in those variable names. Okay. Well, isn't that lovely? It's not often that this is the case in Learn, but sometimes equals, and let's just see if I can do this the laziest possible way. Let's see. Okay. And then we'll do these and return them. Return those. We've got another one. Okay. Has no attribute sorted copy. Oh, okay. I see what's happening. I need to call, I actually need to call the function and do it here. Okay, so the one time I don't like write a test right away. That's what it was asking for. I thought it meant it wanted those as local variables in the function, but let's try that out one more time. All right. Parameter 1 is not defined. Isn't it though? What do they call it? List 1. Okay, that's a way better name for it. I like that better anyways. Okay. Oh, the joys of just reading the problem statement, or of not reading the problem statement completely. Cool. All right, copying. So this next section's on copying. Oh, looks like we got another question though, which is good. List methods 2. Looks like there's a few questions in here. Let's see. Find smallest number amongst. Oh, find smallest number. I think I've helped a couple people with this one recently. Find. Okay, looks like this is it. Okay. Oh, I remember. I remember now. I remember when I went through this one. Okay. Let me get in these tests. We'll build it up and then jump into it. Okay. World's longest function name. Candidate. We'll take in list in. Okay. So, let's pass here. I'm all set up, but we have some example code. The person posting it is saying it's immensely unhelpful, but let's just take a look at how they're thinking about it. Okay. So find smallest number amongst mixed elements. So let me get a clear idea of what our goal is here. The function, given a list of elements of various types, that's what they mean by mixed elements, returns the smallest number within the given list. If the given list is empty, it should return 0. If the list contains numbers, contains no numbers, it should also return 0. So if it's empty, it should return 0. So finding the smallest number amongst a collection poses an interesting challenge because you can't just go like see, well, if this number is less than the last number, then make that the new smallest number. You can do that with the maximum, with finding the largest number, because you can start the number at 0, and you can say, okay, well, if I find a number that's greater than 0, then I'll make that the new largest number, and you can keep doing that if the current number is larger than the previous largest number, make that the largest number. and basically it's down to like where that boundary is. What you can do sort of as a workaround is, and I had somebody uh, got this to work by just setting an arbitrarily high upper bound and just seeing if it's less, if any given number was less than that number. So you could just start it at like 1,000, but what if the smallest number in the list is like 143,000 or something? So you don't know what the smallest number is. The smallest number could still be a large number. So one thing you can do is you could go through and try to find the largest number. And once you have the largest number, you could set the smallest number equal to that, and then trace that back into the smallest number. So that's one way to do this. And I'm thinking, how would we do this? Yeah, let's just jump into this. First goal here is to find something that is a number. So let's just do this. Let's say for element in list n. For element in list n, we're going to say if type L in int float. Now, there's in the example code given, the person's using isInstance. I don't like isInstance. There's few things in Python, especially. There's some things in other languages where I'm like, I don't like that. I just don't like it. But there are very few things in Pythons where I'm just like, I don't like that. IsInstance is something that I don't understand the need for. I don't know why this function exists. It's like it does the same thing as what I'm doing on this line, but it does it with behavior, slightly different behavior that's hard to anticipate. And let's just look at that. I'm going to add a Boolean in here. So if I say isInstance L, and I want to give it some things to check if it's an instance of int and float. See, I mean, honestly, I mean, this line is even longer. I don't know. I don't know. Anyways. So we'll see isInstance, int, and float, and let's just print L if that's the case. Right, so here's some things isInstance thinks are ints or floats. 4, 9, yep, false. So isInstance thinks a Boolean is particularly an integer, I believe. Type in tuple of int and float does not make that mistake. There might be something about isInstance that I don't understand, like where that particular feature is desirable behavior. I can't think of why that would be. If I wanted to know if something was a Boolean, I could just say bool. So not sure why that exists. In general, I just prefer this. I think it's easier. I think it reads better. I think the behavior is more predictable. Does what I need to do at any rate. So different opinions about that. You will hear people who say that you should always use it as instance, but that's my case for doing it this way. So yeah, I'm thinking we'll just find the maximum value first. Can't remember what I did for this. I think that's how I did it before. Okay, so let's call this max, or let's call this largest. Largest. Okay, I'll spell it out. Largest value is equal, we'll start it at 0, and we'll say, so if the type of the element is in int or float, and L greater than largest, then largest equals L. Right? So this does the opposite of what we want it to do, but it actually gets us a step in the right direction. So let's start with that. Okay, so that's 9. That's what we want. I mean, that's what we want in this case. So now let's do this. Smallest equals largest, and oh, come on. Smallest equals largest, and from here we can just say L less than smallest. I actually have to spell it right. Smallest. Smallest. Then we can just do that. And then I'll give us 4. So the reason, I mean, if you look, the major difference is I can start largest at 0, and that'll work. Whereas smallest, like that starting, that boundary isn't clear in the same way. So let's just see. Oops, refreshed that. Didn't mean to. Wait for this to load up. What was this, 12 or something? Okay. Broken. Okay. So let's see here. Oh, it looks like is my name wrong? Find smallest element. Oh, this is the wrong challenge. Okay, well that's why. Okay. Looks like this is my code from before. So we'll come back and look at that, see how I did that there. Correct, okay. So this is a working solution to find the largest one first and then the smallest one after that. This does assume that the list will never have negative numbers though, which, you know, might not be the case. Or does it? Oh no, actually it would work with negative numbers. Huh, yeah, okay. So I had, this is a bit of a mess here. Let's just see what I had here. Oops. So let's see. Before I had this solution, it looks like, and I turned it into this try except thing. Yeah, right. So this was a slightly different solution where we can start smallest at none, right? And then in here we can say we can break this condition out and say if smallest equals none, or the element is less than smallest if it's a number, and it can have a less than value associated with, then we can do this. The only thing is we have to essentially do this condition twice, which is kind of funky because if there are no numbers, then we need to set smallest number equal to 0 to return it. Or we can just return 0. So if we make it all the way through the loop and there were no numbers to add to smallest number, then yeah, we can go from there. Or then we return 0, excuse me. And then finally, there's this last solution here where I'm using error handling. This try except, and basically, oops, I keep accidentally reloading this page. Dang it. So this last example uses error handling. And it catches a value error. I think if there are no, where was the value error? Yeah, I think if min doesn't have, if min has an empty list, then we know that we should just return 0, but it won't return 0. The minimum value of an empty list is not 0. You know, if you think about it, right, min should not assume that it is 0, because it's not. So yeah, so in this case, all I did was element for element in our input, which is array. If the element is of type enter float, and then if we end up with an empty list, min will throw a value error, and we'll just catch that value error and return 0 instead. So that's what's happening here. A few different approaches. Cool. That's a fun one. I would say, I mean, honestly, I would say this is, I don't know, easy is, there's a point where it starts to feel natural, and like, I'm not saying that to brag. Actually, if anything, like the opposite. Like, it's kind of like riding a bike. You know, anybody can pick it up and do it. It's like there's a bit of a learning curve, and it feels really weird when you first start riding a bike or start programming. But then there's a point where it's just like, I mean, there's like kind of a couple little things like realizations, right? Once to get through, like the big thing is running your code constantly, realizing that errors are your friends and that they're there to help you and make your job easier as a programmer, right? You see how much, how often I run my code and how much I get errors, and you know, you could write me off as a hack, I suppose, if you wanted, but I get things done, so it, it works for me. And I'm not the only one who has that attitude. So that's one thing, and then another thing is just realizing that almost every problem can be solved with an accumulator pattern. Definitely not every problem can be solved with an accumulator pattern, but there are times when it feels like, oh, I just went and solved, you know, 40 problems on Code Wars or whatever, or I did, you know, I've been writing code all day at work or on my personal project or whatever, and I just implemented like one different kind of accumulator after another. Um, yeah, I don't know. Those are two like huge realizations that I had, each of which were like once I kind of started rolling with those and started running my code all the time and started realizing I can just assume most problems are going to be accumulator pattern problems. Both of those like made coding way easier. So, you know, one day you too could find this easy, uh, or make it look easy. It's a very learnable skill. Okay, so we have a comment here about the solution. So if I understand the solution using the two loops, the first loop establishes the largest. That is correct. The first loop does establish the largest. And then the second loop runs through the same array. Yep. Compares all the instant float values to that largest value and continually arrives at a smaller and smaller value in each comparison. Yes. Yep, that is correct. That would be a good description of that first solution. Cool. And then I kind of like this second solution too, where we're starting smallest at none. I think that's another good way to, I mean, all three of these are good ways to solve this. This one it's kind of neat. It's sort of the most advanced, and it's starting to get into that territory of like, you know, I don't want people to look at this and say, oh, well, if you can't write this, then you know you can't program or whatever. You know, this looks really intimidating, or it can look more intimidating. I'm using comprehension inline with men and some error handling features. So yeah, it's good, but it you know, I don't like showing solutions like this too much because um, sort of simple loopage just gets a lot done, and it's fine. Cool. All right, I'm not seeing any other questions at the moment. We have a section on list copying, though. Again, this feels like a major downshift in terms of. No, you know what? This is worth going over because copying an object necessitates the understanding of what it means to copy an object, which is it's a simple idea, but it's there's some subtleties that are worth emphasizing. This was another really important realization that I had too, actually. Understanding mutability, that like, well, I would say this is not as important as the, you know, as Pinnacle is central to like my becoming a good programmer to as the other two that I talked about, but this is a good realization when I realized this. Understanding what's meant by mutability, right? So we talk about this thing called mutability, and it gets described as when a mutable object has a change in its value. And it's easy to think something like, okay, so if I have x equals 0, x equals 1 is mutable, is a mutation or something. This is mutability. This is, to be clear, this is not mutability. Mutability regards the data type itself, or the object, more abstractly than the Python built-in data types, right? So integers are all the data types that I've ever talked about in Python are all classes. They're all objects in Python. Python being an object-oriented language, and we can tell if an object is mutable if we look at the methods, and if any of those methods cause a change in the value. Right now, if you're thinking, if that seems confusing because you're thinking, well, what method would change an integer? If that seems confusing, then it should, right? Because what does it mean to change an integer, right? What happened here? Are we changing the integer 0 to the integer 1? No, there's no like altering of 0 to transform it into 1, right? You might think, well, maybe there would be if we said x equals x plus 1, right? Or x equals 0 plus 1. Like maybe this transforms it. This doesn't change 0 into 1 or anything. This just gives you the result of addition, right? 1 plus 1, any number plus any number. Doing an operation like this doesn't change the operands. It just tells you the result of that operation with those operands, right? So 0 plus 1 does not change 0 or 1. It just gives you the sum of 0 and 1, which is 1. So this doesn't change on the data type level. What this is saying is we have an identifier. An identifier is the name portion of a variable. This whole thing is a variable. A variable is an identifier that points at an object in memory, right? So the identifier x is pointing at the integer 0, which is an object in memory. And that's what we're saying. That's what line 235 is saying. What it's saying is that point the identifier x at the object 0. And then on 236 is saying point the identifier x at the object 1. Right? So some languages will talk about pointer mutability. Python doesn't we don't think about the identifier or the pointer being mutable, although some languages do use those terms. But for our purposes, yeah, we don't think about pointer mutability in Python in that way. We just say the variable can be, assigned to the identifier can be pointed at any object in memory at any time, right? And that's not what we call a mutation, right? So why am I talking about this in the context of copy? So here's an example of what mutability isn't, right? Here's some data changing. Integers are immutable objects. Strings are immutable objects. Tuples are immutable objects. We could do various transforms on them, right? Like we can do string.lower. String.lower doesn't change the string into its lowercase form. It gives you back a lowercase version of the string, and it keeps the original string intact, right? A mutation, if that were a mutation, string.lower would change the string that it's called on to its lowercase form, but that's not how strings work in Python. Or integers or tuples, those are all immutable types. So let's talk about immutable type, lists. And this is where copying comes into play, right? So if I have, let's look at a numeric counter, right? N equals 0, n plus equals 1, which is like saying n equals n plus 1. right? N plus equals 1, N plus equals 1. So if I print N, it's going to be 3 here, right? So this is how I alter a numeric pointer, right? So we still have plenty of flexibility with immutable objects. But with mutable ones like lists, right? If I add stuff to a list, it's going to be list.append, right? Notice how I didn't do list equals list with more stuff in it or something, right? Like I'm using this tool that is built into the list object called append, and I'm going to append onto it. So append mutates the list. If I append 5 and print list, we'll have a list with 5 in it. And if I append multiple things, we'll have those multiple things in the order that I called the append. So we should have 5 and then 4. So append is creating a mutation. It's causing a change in the list. Okay, promise we're going to come back around to copying, right? So let's do this. Let's say I have a list and it's got hello, there, and what I want to do is write a function print add name takes in my list. I'll change this to my list, and I'll say def add name takes in a list, and we'll say what we want to do is if I say add name takes in a list and like a name to add, so if I want to say world, if I want to say my name, so this should, in either case, this should give me a list with the name on the end of it. Okay. Okay, so these are my expected results, right? So if I say, okay, so I want to return this list. If I say list.append name, and then I return list, seems innocuous enough, perhaps, to some of you. Perhaps some of you see what's going to happen here. What happens if I print my list? Think about this. What happens if I print my list? So I'll take you through this again. We have our list initialization here. We're initializing our list. We're passing that list to our function here. We just have a couple little mini tests, and our function logic is we take in a list and a name, we append the name to the list, and then return the list. Seems innocuous enough, eh? So notice this did not, the first one succeeded, right? The first one did this correctly. The second one still has world in it, right? So the new value of the list in this global scope, right? This is just a list from somewhere else. You could imagine this like, here's some code that somebody wrote somewhere in a library from somewhere, right? Maybe it's you or a coworker or whatever project you're working on, and where you've got all your code in modules, which is pretty standard. And then this is your implementation, like where you're implementing everything, right? So this function, wherever it lives, you've got this data, this list, you just pass it into your function, and it literally alters that list. It changes that list. It's caused a change in the value there. So we don't want that to happen. So in general, or I say in general, let me rephrase that. Never, ever, ever do this. Never write a function that alters one of its inputs, right? If you must cause an alteration in the function, you can do it on a variable that lives in the function. So if I said this list equals, I mean, you see me do this all the time where, I have a list and we say for whatever, we have like an list accumulator pattern, and we append to that list. But every time the list that I'm appending to is local to the function. So what we want is we want to still return something that has the same data as the input list, but that's just a different list, right? We want to do the alteration to a different list. So what I'm going to say is list equals list.copy. And what this is going to do is it'll say, it'll make a copy of the input list and assign it to a variable of the same name. So I'm changing the pointer to a different list that happens to be a copy of the input, right? So now in this case, we'll get the correct results. Okay, so hello there world, hello there Clark, and hello there. So notice my initial list stayed the same, right? This wasn't altered by my function. Cool. So all that whole long conversation to talk about copy. So copy is a pretty simple thing. If you want some simple kind of rules of thumb around this, like if you take in a mutable data type, lists, sets, dictionaries, and you have any doubt in your mind about whether you need to copy it, it's not going to hurt to copy it. It may be an unnecessary step, but if you have the thought like I need to take in a list and then change it, or I need to take in a dictionary and then change it, then copy it. Then you should definitely copy it, right? Often it's I need to take in a list and like analyze it, or run a loop through it, or have it be a reference for you want to check membership in that list at some point with something else, right? So you're using it as a reference for your function to use, but rather than a target for being changed, right? So you can cause mutations in your function. Just make sure that wherever that mutation is being caused, it's on an object that was created inside the function. Even though this has the same name here, it's a different object, and it was created inside the function from this copy here. So yeah, so just to sum that up, when in doubt, just copy. Okay, cool. So what would be the incorrect way of copying a list? So yeah, so I forgot to mention, there are a couple other things that will just give a copy, a de facto copy, right? So one way is what we can call a full slice. A single or double colon doesn't matter. I always use a double colon. In all my slices, I put in both colons, but quite often you'll see a single one, usually. So a full slice, this is a valid slice, even though I'm not specifying a start, a stop, or a step. Remember, with a slice, if you don't specify a start, it's going to start at 0. If you don't specify a step, it's going to end at the end. If you don't, or a stop, it's going to end at the end. or it's going to stop at the end. If you don't specify a step, it's going to take steps of +1. So this is start at the beginning, go to the end, take steps of +1. It's a copy. Any slice, whether it's a full slice or any other portion, which is more often how you use a slice, you'll slice to some portion of the list. Any slice gives you back a different list with a different ID in memory. So we can do a full slice like this, and it's a de facto copy. We can also cast our list as a list, right? Want to be clear here. This is sometimes called a shallow copy. Let me be a little bit clear about what this is. Let's call this new list. Oops, I meant to put an underscore there. So this is what's called a shallow copy. What we've done here is not a copy at all. It's called a shallow copy, although it shouldn't be. It should really not be called a copy at all, because what we've done is we have an object in memory that has 2 pointers to it, which is legal. It's fine, and there might be times where that's totally fine to do. I think maybe it's something that you'd want to avoid, because if you have the idea that new list and list are different objects, with this kind of quote shallow copy, this is not. These are not different objects. These are the same object. So if I change new list and I print list, it's going to reflect the changes I made to new list, right? So this is called a shallow copy. When you hear the term shallow copy versus deep copy, you know the difference. Deep copy is the other examples that I just gave. The reason it's important to know those is you'll see them, but if you should just use the copy method. When you're actually coding, you should just use the copy method, in my opinion. If there's another stylistic preference that you have for one or the other or whatever, then it's your prerogative, it's your code. So long as it works. Okay, so which is the incorrect way? These top 3 will create valid copies, and this bottom one will not. What would the result of print new list be after running the following code? So we have our original list, we have our new list, which is a copy. We alter the original list. So we altered the original list after we assigned a copy to new list. So that means new list has the original contents. In the code cell below, complete the following. Make a copy of starting list in a variable called sliced copy. Okay. Sliced copy. Copy, and list copy. Okay. So we'll say slice copy equals starting list. Slice copy. Okay. And this is copy. Dot copy. And this is list copy. Oops. Forget I can't do that highlighting trick. Okay, cool. There we go. My guess is that this will work no matter which kind of copy you use. I always like it when I don't know why, but I always like it when I can break the tests and learn just a little bit. Probably says something about me, but that's what I like to do. Okay, there's some copies as well. Awesome. All right, looks like we're at our usual ending point. But yeah, hope this was valuable. Hope this was helpful for folks. Thanks for everybody who asked a question and for the interactions. I appreciate it. It's what makes study halls good. So yeah, definitely feel welcome to DM me, reach out if you have any questions about anything, and I'm happy to help however I can. Go ahead and drop us a like on YouTube. Commenting and subscribing also helps as well. We're trying to build out the channel, so yeah. So I guess I never know how to wrap these things up. I always get kind of awkward, but I appreciate y'all's patience anyway. So have a good day, and I'll see you all on Wednesday when I stream next. Cool. Bye-bye.